Good evening, engineering managers. We are presenting to you today on the subject of identifying critical path activities within a project and also what you can do with that information. My name is Greg Larson. Professionally, I manage capital projects for an ink company, and amateurly, I am restoring a classic home.
I am Rachel Hott, and I will be presenting with Greg this evening. I work in Des Moines as an engineer at a company that makes medical devices. As Greg mentioned earlier, this evening we will be briefing you on critical path management. From this presentation, it is our hope that you will better understand what is a critical path and its usefulness, learn methods of tracking tasks and be able to determine the critical path from those tasks, and lastly, recognize the uses of critical path in project management. As defined by businessdictionary.com, critical path is the longest sequence of activities in a project plan which must be completed on time for the project to be completed on due date. Determining your critical path early is especially important because projects have a tendency to go over budget and exceed their schedule. One study of almost 1,400 IT projects found that 17% of those projects had a cost overrun of 200% and a schedule overrun of 70%. Identifying and using the critical path is key to managing your scope, schedule, and cost of a project. Using critical path management to streamline and prioritize tasks has proven to be useful in many different types of projects. Israel Aircrafts used critical path management to improve their average plane maintenance service time from 3 months to 2 weeks. This saved them money in which they were paying previously for late charges. Critical path management can also be used for one-time projects, such as when Harris Semiconductor decided to build a new plant. They put extra effort early in the project to determine those tasks which were on the critical path and were able to have their plant running at 90% within 14 months, though the industry standard was 46 months. So by now, you're all probably asking, how do I identify the critical path for my project? Well, for that, I'll turn this back over to Greg.
The first computational technique we will cover is called, accurately, the critical path method. This is a deterministic approach to scheduling a project where the activities are displayed as nodes on a network diagram, as you see in figure 2 on this slide. The corresponding chart on the left lists the durations, resources, and then res-dur, what you might call man-hours. Often with this type of diagram, the user will write the activity length right on each arrow on the flow chart. For example, both arrows coming out of the node A box would have the number 2 attached. The user then adds up the numbers of each arrow along the different paths, and the longest one wins, or becomes known as a critical path. One nice feature of this method is the simplicity of the diagram. Task dependencies are obvious, and the table of information is intuitive. When you share this diagram and chart with managers in other departments, they'll probably understand without much explanation. Of course, there are also some drawbacks to this method. First, this flowchart only has 9 activities. I'm currently working on a project that has around 130. If you start writing information directly on the diagram, like the activity durations that I mentioned earlier, the flowchart becomes saturated pretty quickly, which takes away from some of the simplicity. Second, activities D, E, F, and G are aligned vertically in this network diagram, but they're not taking place at the same time interval because the diagram does not lay nicely on an overall timeline. So the critical path method is a tool that works nicely for tasks with durations that are well defined, perhaps because you've done the same thing over and over again. But what do you do when tasks are poorly defined and you don't really know how long each one will take? Fortunately, the US Navy can help us out. The Program Evaluation and Review Technique was invented for the Polaris Submarine Weapons Systems project in the 1950s. This is also known as PERT, or PERT. From what I understand, this was one of the largest weapons projects executed by the military at the time and had a reported 3,000 different contractors. Since there weren't many comparables for scheduling, some wise consultants developed a method where educated guesses were made by engineers and managers at an optimistic, a pessimistic, and an expected duration for each activity. Confidence levels were then assigned to each task based on how close each of the estimators were to each other. On the bottom left-hand side of this slide, you can see that the most likely completion time was given a weight of 4 times that of either the optimistic or pessimistic completion times. This information is then applied to a network diagram, like the one we saw on the previous slide. Again, add the durations of the arrows along each path, and the longest equivalent time identifies the critical path. A strong advantage, in my opinion, of the PERT is the acknowledgement that task durations are not written in stone. They will vary throughout the course of the project. Unfortunately, this also makes including economics for each activity difficult, though there is some software that helps with this analysis. Also, like the critical path method, the diagram for PERT charts is simple to understand. More information can be included on each node, such as the range of completion and start times, slack time, and duration, but that makes the chart less intuitive. So what can we do to simplify the visual representation of task duration and identify slack time? For this, I prefer the Gantt chart, the final method of tracking critical path activities that we'll talk about this evening. As was pointed out a few weeks ago in another presentation, there are various software programs that are useful for this type of organization. Any commercially available program will be able to automatically identify the longest sequence of activities that needs to be completed, which in this slide is identified in red. As engineering managers, many of you are probably familiar with this type of project tracking. If you use scheduling software such as Smartsheet, Primavera, or Microsoft Project, which, by the way, can generate network diagrams to use as critical path method or PERT tools, you can assign costs to resources and resources to each activity. This information being automatically disseminated through the entire activity list helps identify overscheduled resources, so the project manager can work to rearrange the schedule in a way that will improve the chances of success later on. Another advantage of this style schedule is the entire project overlays nicely onto a cohesive timeline, which you can see on the top row of this graph. In my experience, this helps non-engineering managers understand the larger picture of the project that may be critical to the rest of the organization, say when assets can be depreciated. Also, each activity is represented by its own bar and links to dependents with arrows, which makes the identification of activities with lots of slack, or activities that are completed before absolutely necessary, easy to identify. As expected with any scheduling method, there are disadvantages. One being that, to fully take advantage of the tracking ability of the software, the completion percentages need to be manually updated, which takes time. Time is hard to find. Also, for massive projects, though taking many months or even years to complete, the chart becomes quite large and difficult to share in regular reports. Now that we've covered some ways to identify the critical path of a project, what can you do with that information?
Well, Greg, the information you gain from identifying and conceptualizing the critical path can be very useful in project management. A Gantt chart or other visual representation of project tasks is great for team communication. It is a way to make sure everyone is on the same page and know what tasks are going on and when. It can also help your team to plan for times when they will be more occupied with this project. In addition, these charts are useful for managing resources. Some projects require the use of equipment that is shared between multiple projects. The Gantt chart helps to plan when such equipment will be needed. Also, certain tasks or milestones may require purchasing items, and so a Gantt chart can show when these tasks are to occur so the budget schedule can be laid out. Next, a critical path is a great tool for showing the effects of project scope changes. For example, if a customer comes to you as a project manager asking for a change or modification, you can show them that either adding that change will affect the critical path and the project will take longer to complete, or you'll be able to complete that change in parallel with other tasks, thereby not affecting the project schedule. Lastly, identifying the critical path is crucial for effectively crashing or shortening a project, which Greg will talk about further.
Okay, engineering managers, you have a Gantt chart, and now it's time for you to apply some pressure to your project managers or subcontractors. The Gantt chart on this slide is a slice of one of the projects I'm currently executing. This started in September and will finish in June of 2016. I delivered the engineering activity list to the plant manager, and she identified production milestones for the plant, like inventory levels and shift schedules for the time of construction. Then she came back to me with an opportunity, as she calls things of this nature. Tank 600 is a large batch tank that will be out of service from demolition up until SAT, or site acceptance testing. No production can take place in this vessel at this time. The tank produces about 50,000 pounds of product per day, and the Gantt chart shows it out of service for a minimum of 10 days. So that's 500,000 pounds of missed production. In round numbers, the profit of this material is about 20 cents per pound, so $100,000 lost. Armed with this information, it's time for me to get to work. If I were in front of you, I'd ask if, due to the nature of the Gantt chart timeline, any of you saw some obvious ways to shorten the downtime. But since this is a recording, I'll tell you that I see weekends. This work is electrical and mechanical in nature. Those types of contractors have multipliers that are pretty effective in modifying costs for weekend or overtime work. They even adjust for productivity losses of each worker when days are more than 10 hours long. So I can move demolition from June 6 to June 4, and the same for activities the following weekend. At this point, I've started production 4 days early and increased my costs around $20,000 for the weekend work. This increased cost is still less than the profit I expect to earn, so I can keep cutting. I then looked at extending working hours from the contracted 1 10-hour shift each day to 2 12-hour shifts, working around the clock, shortening the remaining downtime even further. Each schedule improvement comes with a cost, and the costs are weighed against their respective gains. The best values are chosen first, and the decision becomes strictly algebraic. And that, my fellow engineering managers, is one simple example of how you can crash the critical path to shorten an event.
From this presentation, we hope that you are able to take away the definition of a critical path, the ways in which a critical path can be represented through a network diagram or a Gantt chart, and how you can use these tools in the critical path evaluation to aid in team communication, managing resources, and demonstrating how changes may affect your project. We'd like to thank you for being with us through this presentation, and we encourage you to ask us any questions or discuss your experiences with critical path management, Gantt chart, or anything else related to this topic.